Day 10, Notes and Daily Practice, is our second day of review for rational functions. Yesterday we looked at adding and subtracting, multiplying and dividing rational functions, and today we'll focus more on the graphs of rational functions. So I'm going to do a few of these with you, and then the rest you can try for practice, and then check your answers in the Day 10 Daily Practice answer key. The first one I want to go over is number 1. Use what you know about shifting functions to graph the asymptotes as dashed lines, and the function f of x equals 1 over x plus 1 minus 4. Label the asymptotes. All right, so all of this depends on this one function, the mother function for this chapter, the parent function, y equals 1 over x. So let's graph that just so you can see what that looks like. All right, so here it is. There are two asymptotes or invisible boundary lines, and one of them is at y equals 0, and the other one is a vertical line at x equals 0, and then our function looks something like this, where it approaches but never quite touches the asymptotes. So here is our mother function, but now we're going to shift it. So let's talk about the shift. The first shift is inside the parentheses plus 1. How does that shift the graph? Up, down, left, or right 1? And plus 1 we know shifts to the left 1. And then minus 4, hopefully you remember, shifts down 4. So it's going to shift the whole graph and the asymptotes left 1 and down 4. So let's start with the left one. X equals 0 was our vertical asymptote, but now it's going to be shifted left 1. And so now we have a new equation right there of our vertical asymptote at x equals negative 1. And then everything shifts down 4, including this horizontal asymptote at y equals 0. So now I'm going to shift it from the x-axis down 4. 1, 2, 3, 4. All right, so here is our new, that should be more dashed, our new asymptote, and that is at y equals negative 4. And then we can graph our function, which I'll graph in blue again. And so it's going to approach the asymptotes but never quite touch. Whoops. Okay, so here's what our function will look like. Okay, so it's shifted left 1 down 4 from x equals 0 and y equals 0. So now let's write the equations of our asymptotes. The vertical one is the one that goes up and down. It's the x equals. So x equals negative 1 is our vertical asymptote. The horizontal asymptote shifted down 4. So y equals negative 4. Domain is all possible x values, and you can see this blue line goes everywhere left and everywhere right except for that orange line. So the domain is everything except the asymptote. So if you can figure out the asymptotes, the domain is pretty simple. It's just everything but the asymptote. X cannot equal negative 4. And then for our range, again, you can see our graph goes all the way up and all the way down, except for at this asymptote right here at y equals negative 4. So we're going to say for our range right here, y can be every value except it can't be the horizontal asymptote. So y cannot be negative 4. So again, if you can figure out the asymptotes, the domain and range cannot be the asymptotes. All right, there's one for you to try going backwards and sketching it. The next one I want to go over is how to do a hole, but maybe I'll do one vertical asymptote hole and horizontal asymptote, and we'll take a look at the graphs. Okay, so number 3, write the equation of the vertical asymptotes. Remember to factor first. Okay, so I'm just going to do one really quickly. I'll just do the first one. Factor if possible. So this becomes y equals x plus 11 over x plus 5, x minus 5. And the asymptotes are what make the denominator 0. And there's nothing we can cancel, so we just look at the bottom. And there's two vertical asymptotes, VAs. And the first one is x cannot, or x is at negative 5. There's your vertical asymptote. And x is also at 5. So if we were to draw this graph right here at negative 5, there would be an asymptote. And at positive 5, 1, 2, 3. There would be an asymptote, and your graph might look something like this. I mean, it depends on your horizontal asymptote, but it could look something like that. Okay, so again, the asymptotes are what makes the bottom, the numerator, 0. So our answer is negative 5 and positive 5. It's like finding the zeros. Okay, so that's vertical asymptotes. Let's look at how you find a hole. I'll do the second. I'll do the first one. Okay, so this one right here, factor first. So it multiplies to -2, that adds to -1, and that would be -2 and 1. And the bottom's already factored. Okay, so there's a whole here. A whole is what makes, what's the same on the top and the bottom, and what makes them 0. So the whole, the x value is at +2, because 2 minus 2 is 0. All right, so there's the x value. But what remains, so here's what remains, the x plus 1 remains. So now to find the y value, right, because this is y equals, so I'll just put a y equals, we're going to plug the 2 in here and find the y value at the whole. All right, it's 3. So our whole is at the coordinate 2, 3. There would be a whole. Okay, so there's one more for you to try. And then let's take a look at the horizontal asymptotes. Again, I'll just do the first one. Okay, so horizontal asymptotes, you don't even need a factor. You just look for the king of the top and the king of the bottom, the highest exponent. And here it's 2x squared and x squared. When they're the same, you divide them. So 2x squared divided by x squared, the x squareds cancel. So the horizontal asymptote is y equals 2. So this, you would have a horizontal asymptote if you go 2 up and draw a line across. Okay, so either they match and you divide, or if it's bigger on the bottom, the horizontal asymptote is 0. Okay, and then there's a few more types of problems, word problems and graphs, so let's just do one of the graphs. I think 7 looks, let's go over 7. Okay, so this one right here, first step, if possible, factor, and we can factor the bottom, the numerator. So we get -4 over, we can divide each of these by x. So think about dividing each by x, and we have x minus 3. All right, so there's the factored form. The vertical asymptote is what makes the bottom 0, and there's 2 of them here. The first one is at x equals 0, and the second one is at x equals 3. So it's like finding the zeros. Okay, so if we were to sketch that at x equals 0, there's your vertical asymptote, and at x equals 3. 1, 2, 3. Okay, so here's x equals 3. All right, the horizontal, there's no holes here, nothing same on the top and bottom. The horizontal asymptote, you look for your highest power of x squared. It's on the bottom. So that would be y equals 0. So here's your horizontal asymptote at y equals 0. And then we would graph the function. And I always forget if it goes down, up, down, up, down, up. So I'm just going to graph this really quickly. Desmos. Okay. So for this one right here, for graphing it, it would be -4 over, and it was x squared minus 3x. All right, so that's down, up, down. So let's do that. Let's use pink. All right, so this is down, up, down. All right, and our domain is everything except a vertical asymptote. So x cannot be 0 and x cannot be 3. And the range is everything except the horizontal asymptote. So y cannot be 0. All right, so the rest, there's a few more problems left for you to practice and check your answers. And of course, let me know if you have any questions.